Welcome everyone to today's virtual training. We've got attendees from Pennsylvania to Colorado. We've got village clerks, building inspectors, engineers, planners, biologists, emergency managers, and educators. We're thrilled to have you all. This is kind of a really exciting geographic reach that we've accomplished with this topic, as well as professional spectrum. This is our very first time offering a training on the topic of our changing climate. And I really could not be more excited to introduce our guest speaker. He's Doug Kluck. He's the Central Region Climate Services Director with NOAA. That's the National Oceanic and Atmospheric Administration's National Center for Environmental Information. Doug is from Nebraska, but has lived in Kansas City since 2000. He's worked for NOAA since 1992 with the National Weather Service and now NCEI. His region's expansive. It covers 14 to 16 states from Colorado to Michigan, and Doug's responsibilities include coordinating and informing on climate service activities among federal, state, and local, tribal, academics, and private interests in the region. His engagement in these groups and interpretation or translation of climate information, monitoring, directing research, education, and outreach are all parts of his activities. So Doug wears lots of hats, does a lot of things. And we thank him for making time for us. During extreme climate events, such as drought or major flooding, Doug coordinates information response, attribution, and assessment among core partners at regional level. And he's also graduated from the University of Nebraska-Lincoln, go Huskers, with a bachelor's of geology, and his master's degree is in geography and climatology.
All right, so thank you very much, Adele and Asa, for inviting me and Department of Natural Resources and all of you on the webinar, or what are we calling this? Zoom today. Gosh, there's so many different platforms. So yes, I'm from Nebraska. Just a little bit more about myself. I'm probably going to talk about my brother more than me. So there's somebody from Davenport down there who probably knows the last name. My brother is Fred Kluck, who coached there for many, many years in Bruning, Davenport, Shickley. So go Storm, I think it is. Anyway, we grew up in near Columbus, between Columbus and Schuyler, in Richland, near Richland, I should say, and lived on a farm till I was about 6, moved to the big city, and went back and worked in the summer on feedlots, things like that. So if you know anything about the Klucks in Nebraska, you'll know that they did a lot of feedlot work. So that's my origin story. And although I'm not living in Nebraska, I still, that's where my heart is. So sorry to all you folks who are not from Nebraska on this call. I'm going to focus on Nebraska for the most part. Although we're going to start sort of globally, and let me just, whoops, I guess I got to go over here. I got to be able to change my screen. I wonder how I'm going to do that. Oh, there we go. I'm going to cross a whole bunch of subjects in, unfortunately, very little time. Almost everything I talk about could be done separately. A lot of these issues are bigger than what I have time for. So you're going to get a little taste, especially some of the tools that I don't go into great depth, and you're going to say, what the heck is he talking about? And I'm really saying either get someone else to or me or whatever to come talk to you more about it if you really want to know more. In other words, reach out or to spend some time on some of these tools yourself. I'm not saying they're all self-explanatory, but they're supposed to be, right? Yeah, so I'm going to talk about all those 5 things in some depth. That picture on the upper right is from 2019. That's down, I should say all these, not all these pictures, but that picture in particular was taken by Jim Hoppy, who is an old family friend of ours, down just near Schuyler. A lot of the land down there got ruined. There's some drought pictures from the Missouri River on the left. lower left. And that's actually, I think that one is from a fire off in the distance. I think I took that one while driving to Rapid City. But nonetheless, all these things are possible in Nebraska, or are from Nebraska or near. I'm not going to go into detail about this. People ask me if I get on a plane and I sit next to somebody and we strike up a conversation. Often the conversation is, "Hey, what's your name? What do you do?" And oh, you're a climatologist. Well, oh, so do you believe in climate change? And my answer to that often is, well, I don't like to think of it as a belief system. I understand the science behind it. I understand the physics behind it. So if you're asking me, is climate change something that is real, and are we having an influence, we being humans, having an influence in this world? I always say, yeah, because I understand the science, right? I also understand what's coming in terms of data. And I'm going to show you some of that. I'm not going to go into what the greenhouse effect is. There it is for you. It is something we need to protect ourselves from being too cold or too hot, to be honest with you. But we've shifted the balance, we'll say, by burning a lot of fossil fuels and other things, releasing other gases that are trapping a lot more heat than we should. Yeah, so we're outside the historical range. That's our 2020 average of parts per million of CO2 in the atmosphere right now. This is the way we measure it. We do measure CO2 constantly, and there's several places around the world that is done, and we do know it's going up. We also can go back and look at ice cores and trees and all kinds of great things. To the, relatively recent past, 800,000 years ago, believe it or not, is the relatively recent past in geologic terms. And then we look at some of those dots way over to the right, and you see the 2020, that's how many parts per million. Sorry, I can't remember how many parts per million we're up to, but it's increased since then. And then you see a purple and a red dot up there. The purple dot is if we get some handle on our emissions relatively soon. And the higher scenario is 2100, at 2100 if we don't. Okay, so if we continue sort of as we currently are, that higher scenario. So there's a lot of parts per million, which you can see based on the last 800,000 years, at least, is a little bit above what I guess it should be at. And we're going to see what the repercussions of that are. Okay, looking at the top 10 years in the world, globally, in other words, since 1880, in terms of temperature, these are the top 10. Everybody loves top 10s, right? So what are the top 10 years? Well, they all have a 2 and a 0 in front of them. So that tells you something. So basically it's the last 10 or so years that have been the warmest across the globe. There's a couple in there that don't quite fit into that, but for the most part, the world is warming. Okay, since 1880, those are the top 10 years that we've had, top 10 years of temperature measured. This is what it looks like, if you will, from a bar chart point of view, and years across the bottom, and the amount of temperature increase to the left. Okay, there's some statistics, and we don't need to get into how important these things are. They're all important, don't get me wrong. Probably the most important one is the very bottom one, which says the highest ocean content. The reason that's a big deal is that oceans tend to suck up a heck of a lot of heat that we produce, if you will, or that gets into the atmosphere. And that's a buffer. That's a huge buffer. It's a buffer, but it's also going to last a while. In other words, even if we said, okay, we're not going to use one more drop of fossil fuel, for example, or burn any more coal today, we have built into the system a leg of 100 or a couple hundred years that are going to continue this, because the oceans are warmer than they used to be, and that's a huge area and a lot of heat. We built into this equation continued heating for the next 100 or 200 years. Not as much as we would if we continued to burn fossil fuels, however. So anyway, there's some records for you, just kind of giving you what last year was like in terms of the world and all that business. These maps, the one on the left is the annual land and ocean temperature trend from 1900 to 2020. So basically the whole record. Where is it warming? Where is it warming the most? The darker the red or pink color you see there, the more the warming. All right, that's it. And it's warming, and that tells you how many degrees Celsius per decade those areas are warming. Maybe more importantly, though, is looking at the last 30 years, or almost the last 30 years, 1991 to 2020, and looking at the same idea of how fast are we warming. All right. So we're warming at a certain rate over the last 120 years. And then over the last 30 years, we're warming at a much greater rate in most of the world. Not everywhere, but most of the world. And you can see those really dark areas that we're talking about half a degree Celsius per 30 years in that case. Okay. So basically it's saying, all right, we've ramped up the increases in terms of temperature, the rate of temperature gain. What else do we look at in terms of if you will, proxy data, or data that shows us what's going on in the world in terms of sea ice, air temperature over the ocean, humidity, snow, etc. What are all these things telling us? Well, they're telling us the Earth is warming for the most part. Sea level, ocean heat content we just talked about, sea surface temperature, glaciers, for the most part, not everywhere, but for the most part, are receding or disappearing, less snow coverage and all that kind of stuff. All right, so what, right? So one thing that we worry about is, as climate scientists, is what is this doing? What's this doing to our atmosphere? What is it making more likely to happen? What is it shifting our extremes towards, if you will? By the way, that picture in the lower left is on the Iowa side, looking sort of out over the Missouri in 2019, somewhere. I drive a lot. My mother's in Columbus, so I drive a lot up there to see her, and I got other relatives up there. So I drive up I-29 a lot to Omaha and then across. But so it was an interesting year, 2019, driving across. When you could, I should say, when you could drive up I-29. I had to take some detours, obviously. And I'll get to that point in just a minute. Over on the right, you see those two graphs. The one on the top is showing what happens to temperature, the bell curve of temperature, if you will. What's common, what's average, what's not so average, shifting to the right. Shifting to the right, meaning, okay, we're shifting this bell curve. What's the probability of more hot weather or record super hot weather that we're not used to? Say, take, for example, it was Seattle, was it last year or the year before, where they reached 110 or some ungodly number for that neck of the woods. I don't even know what that temperature would be here. I'd be scared to predict, because we can see 110 here on a normal in a normal situation. Anyway, what we're doing is shifting the probability of record heat, and we've seen that, by the way, in the record. More record heat, more records being set on the hot side than on the cold side, and that's part of what we're seeing already. In terms of precipitation, we're also seeing more heavy, faster rainfalls than we used to. More raining cats and dogs than we used to see. Less light precipitation and more heavy precipitation when that occurrence is. And I'll talk a little bit more about why that is in just a minute. Excuse me. All right, looking at the nation, looking at our last 30 years, and we compute averages every 10 years for a 30-year span, by the way. So you're going to see a lot of this 1991 to 2020. That's our new normal, if you will. That's our normal climate for now. And here's what you get when you take the last 30 years and you subtract the last century from it. Where is it warming the most? Well, across the west, across the north, and even in Florida to some degree. There is this big sort of area in the middle, all southeast Nebraska down to Alabama, where it's not heating up as quickly from a temperature point of view. We might argue about whether it's becoming more humid or not, and if it can warm up that much, because so much water is in the air. That's a different sort of issue. Here's looking at 30-year slots, 10 years apart over the last 120 years or so. So starting back in 1901 to 1930, based on 20th century average temperatures, okay, how things have warmed up over time, basically. And you can see evidence of, in the 30s into 1960, for example, you can see the 30s and 50s where we had a lot of heat across the central part of the US, record heat in Dust Bowl, et cetera. And then you can see how things transformed all the way up to now. Okay, so you can see definite warming trend there. One thing I wanted to touch on before we looked at precipitation trends is to talk about how warm air holds a heck of a lot more water than cooler air. And this is one of the issues that we're talking about in terms of precipitation increasing in some areas, not all, but increasing in some areas, and being able to wring out, if you will, that water in the air when cold fronts or whatever cause it to rain. So that's why we're seeing more heavier precipitation as well, is because there's simply more water in the air than there used to be, especially sort of in the eastern part of the US. Okay, so that's just a curve showing, gosh, you can hold a lot more water when you warm up the temperature. Okay, there's the US, the view of the US. Again, comparing the last 30 years to the century before that, and where it's gotten wetter. Well, Nebraska sort of north and east, you can see a big area up there of much wetter conditions over the last 30 years than the century before that. And then really across all the way up from the Gulf, you can kind of see there's sort of an area there as well. In the Southwest, the opposite, where they're having a severe drought and long-term drought, maybe even not even calling it drought anymore. We might even call that the new normal. That's a little bit up for debate. This year is a good year for the Southwest as well as the West, and we'll talk about that hopefully if we have time a little later. Trends in flood magnitude down on the lower left, we're seeing positive trends along where those triangles or the green triangles are. A lot of those areas are seeing a lot more floods in some places, as you well know. 2011, 2019, both massive flooding along at least the Missouri River corridor and some of the tributaries along that. By the way, this was done in 2013. I don't even know if they used 2011 data, but I'm assuming he did. And then we see over on the right, we're looking at heavy rainfall, the likelihood of heavy rainfall increasing. That's the period of record that he looked at, 1958 to 2016. And we see in the East Coast, Northeast Coast, and in the Midwest, the highest percentage of increases in heavy precipitation in those two areas. Still in Nebraska, across the northern plains, it's an increase. It's just not as great as it is to the east. Here's that same 30-year by 10-year jumps across the US as we saw for temperature. You can see temperature, or you can see precipitation changes over time. You can see generally getting wetter west of the Rockies, not the high plains necessarily, but definitely the if you will, the low plains, the middle plains, and all the way to the East Coast for the most part, not everywhere, but for the most part, especially upper Midwest. Okay, and that picture down below follows the 2019 flood, again around the Schuyler, Richland area, I'll say, of the Platte River, and all the new sand that they got to play with down there. Heavy rainfall and the increase in, we talk about return. I know you guys all talk about return frequency, like 1 in 100-year events, 1 in 500-year events, etc. Right? So this is looking at 1 in 20-year return frequencies. And what has happened, just looking at that, just, you know, it really goes for all return frequencies. One in a 5-year return frequency, 20-year, 100-year, whatever. They're all going up. But just looking at 20-year and looking at it seasonally, you can see where the greatest increase in inches has happened. Doesn't mean we're wetter in the fall than the summer or the spring. It just means the increase is greater in fall for Nebraska and the north central part of the U.S. But you can see, for the most part, increases in all seasons, with summer being the least, right? Says something. This one, I know Adele didn't like my phrasing here, so I tried to change it so it made more sense. And this is looking at snowfall, likely increased total snowfall amounts in the northern plains. Those are the cold areas, but an increase also in the proportion of precipitation falling as rain. So wherever you see blue dots, okay, blue dots as opposed to orange dots. So we're really talking about, let's say, Sioux City North. There's a better likelihood of getting more snow annually, okay? But we also see that although you may be getting more snow in those areas to the north because it's cold and it stays cold up there, you know, they say climate change is coming to North Dakota, and people in North Dakota say, okay, you know, we're used to 40 below. Now it's only 30 below. So, you know, you tell me the difference if you can actually tell that. But what I would say is it's going to snow up there a lot. And with more moisture in the air, the chances of that precipitation falling as snow and being heavier or more, I should say, is going to go up. But you're also going to see more rainfall earlier in the season, which can contribute to flooding. We saw it in 2019 as well. I wouldn't say that was necessarily a climate changed storm. Some do. Some people do say that, but it could have occurred in any case. What's hard to differentiate, and I should say this real quick, is that on a particular storm system like 2019, we'll say, how much more did we add because of climate change than would have happened without, right? So is it 1%? Is it 5%? You know, that's so hard for researchers to pull out and say exactly what that number was. Yes, it was an alignment of 25 planets. I get it. I get it. It was hard for that to happen, but golly gee, when it did, we certainly paid the consequences, right? And not extremely predictable either, to be honest with you. Moving on to extremes. Hey, what a nice way to change. Not all these pictures come from Nebraska, but they come from around Nebraska, so they're close enough. You may recognize some of these places. Well, you might recognize one. Well, you might recognize a couple of them. One's pretty obvious. The falls there, Sioux Falls. The big sandbag area down there is the Ottawa Casino, I believe. And that could be any storm. The dust storm out there is Western Kansas. I think the fire is Colorado Springs, and that's a drought anywhere in the upper right. And that's a snowstorm about anywhere in the plains, a blizzard, I should say. That happens to be Rapid City, I believe. And then the big flood, also 2011 in the Crow Nation out in Wyoming. Anyway, moving on. So more frequent, more severe extreme events are occurring. Communities and businesses are feeling impacts. I don't need to tell you folks these things. Here's a disaster trend for the entire nation. Now, let me say a little bit more about this. These are billion-dollar plus events. So I'm sorry if it was only 500 million, you don't make the cut. So, but if we're gonna make a line somewhere and just start counting things, $1 billion seemed like a pretty good number. And the total cost of these since 1980 of these 341 events exceeds $2.475 trillion. Okay, just with those $1 billion plus events. That's not adding all the $100 million events. Okay, you can see they're broken out by color coding by the type of event that you see there. And then the various lines that are going through this bar graph are also cost levels. So you saw 2017 being a very costly year compared to other years around it. 2005 was also, you might be able to remember what happened in 2005 and 2017 and why those 2 years were so incredibly costly to the nation, but they had to do with hurricanes. I'll just say it that way. Hurricanes are incredibly expensive. Now we can argue about whether severe storms, although they may cause $1 billion, are climate change events or not. Yeah, sure. No doubt about that. There's no hard and fast information there. 1980. Okay, here's looking at dollar costs by year and month. Okay, so all these little color-coded lines here, you can look at the top and tell which year is which, basically. So 2005, 2021, 2022, you can see them all in there, and all the other years down below. So we're seeing, you notice a lot of those years are recent. Okay, so we're seeing more of these billion-dollar disasters affecting the U.S. Over time. And here we go, 1980s, 1990s, and they are inflation adjusted, by the way. So it's not like we're comparing apples and oranges from 1980 to 2022. All right. Costs have quadrupled. And there's lots of reasons for this. It's not all climate change. Some of it is people building in places that, and again, I'm preaching to the choir here, building in places you would never guess they would be allowed to build, right? Or be allowed is not a good way to say it. Maybe build where they should know better. But, hey, there's surprises all the time, right? Here's looking at 2022. This is the way we sort of plot it out on a grand chart. Some of you may remember some of these very specific issues that affected us. That Western and Central drought, we're part of that, okay? We get credit for that, if you will. And some of the severe weather occurrences that happened as well. So that's the way we plot it out on a national map. All the stuff I've showed you, for the most part, is online. By the way, I've tried to put URLs on each one of these graphics. So let's boil it down to Nebraska disaster trends, if you will, since 1980. There's the chart. It's a little messy, I agree. You can see the 5-year average cost, the combined disaster cost. Again, some of these, disasters don't really care where the state borders are. All right, they just happen. And drought, you're going to be sharing a lot of these drought damages with Kansas, believe me, and maybe South Dakota and Northeast Colorado. They had pretty bad drought too. So it's a sharing, if you will, of bad news on not all the events, but some of the events. Blair, Nebraska, a few years ago, when they got the huge hailstorm and it hit all those cars, right? That was $1 billion easy. That's an example of a kind of a localized one. Although that one did go into Iowa and cause quite a bit of damage too. What can I say about this? A lot of severe weather in Nebraska, surprise, surprise, but you have your floods. You see 2019 in there. You see winter storms, drought. Those are some of the big ones. Wildfire, I don't know. I don't remember. You guys probably know a lot better than I do. 2012 was a heck of a dry year. So I'm sure you shared in damage in terms of wildfires that year. Looking at disasters by month, here's how they sort of pan out in terms of where drought, severe weather happen to occur. Some of these things linger from year to year, so it's kind of hard to count it. But you see the severe weather in the spring. You see the flooding mainly in the spring, early summer, wildfires later in the year, that kind of stuff. And then if we compare the likelihood, I guess you'd say, of an event in any particular month, you see June is the king. June is the king for for $1 billion disasters in Nebraska, although May, July, and August aren't too shabby. And then that secondary, the secondary bar, if you will, is a chance of 2 events during that particular month. So anyway, I just thought that might be interesting. Again, all this is online for every state. And we'll get into more about the particulars here in a minute. Here's looking at Nebraska again and what the costs are, or cost estimates are, and how this is a collection of all of the events here. I won't go into great detail. I'm just going to show you it costs a lot, and you had a lot of events. You don't have a lot of tropical cyclones in Nebraska. I do want to spend a bit of time on this. This is sort of new, so I want to make sure you folks in particular know this exists. This we can get down to the county level on. So if you're interested in that, and I think maybe even tract level, I think. So we'll see in just a minute. You can categorize each state this way. You can look at disaster costs, cost per year, cost event, cost per million residents, etc. This is cost per million residents. And you can see if I just did costs, Texas, Louisiana, maybe Florida, they all light up because they've had so many billion-dollar disasters and huge, huge disasters, right? So a way to make this a little more fair, if you will, is to look at per million residents or cost of state GDP. That's another way to look at it. I put the menu up there so you can go and look for yourselves at this if you'd like to. Nebraska, is on par, if you will, with Texas in this case in terms of frequency and cost per million residents. Okay, so anyway, you can look at that. I want to make sure that we all know that this is using FEMA's a lot of FEMA information and NOAA information sort of mixed together and come up with hazard risks maps, taking into account all those types of disasters. And we're also, as I'm going to show you in just a minute, we're also looking at potential for cascading hazard impacts. And for example, drought enhanced wildfires produce sort of this burn scars, which means water can't percolate down into the soils. It basically sheds it right off, which when it does rain finally, even a half of an inch in a mountain range where it's been burned can cause a major flood or debris flow in that localized area. So there are cascade effects from various disasters, if you will, or various extreme events. Even if they don't even seem, sometimes it can be death by 1,000 cuts. That's the other thing, especially on vulnerable communities. It doesn't have to be the biggest disaster of all time to wipe a community out. It just has to be a bunch of stuff that happens over time, and and there's not, the community can't afford to deal with it, for example. Okay, zooming into Nebraska, and yes, this is tract level. I see tracts. It's not easy to say. I see tracts on there, so you can actually go in on the website, click directly on the county you want, and we'll get to what happens when you do that. But here's some of the different things you can look at all at the same time for the state of Nebraska, and different shading. So it shows a risk score there from 0 to 100. I don't know a lot about the risk score other than the greater the risk, the worse the situation is for that particular county. And I think I put vulnerability on here too. Yeah, so so the first one is hazard risk. This second one is social vulnerability, even though it doesn't say that on the right. This is the social vulnerability chart. And you can see some of the counties, especially along the Missouri up there, I think some of those are tribal lands and things like that, where some of the socioeconomic issues are there's greater poverty or such, and less likelihood that they can afford a disaster, if you will. And so anyway, moving on. So if I were to, and I clicked on census tract 9642 in Harlan County. If anybody knows where 9642, I had no idea where 9642, but I do know where Harlan County is because I used to fish there long ago. Here's what you get. So when you click on Harlan County, and I happen to click on that, there might be a couple census tracts there. I have no idea. These are sort of the values you get. What is the drought risk? Well, it's 35.77. Well, what's that mean? Well, let's compare it to the county. Oh, it's greater than the county. Oh, it's greater than Nebraska's. and it's a lot greater than the US. So the drought risk is pretty high in that county. Flooding risk, we can look at that too. So freeze risk, severe storm risk, not a surprise, right there in kind of Tornado Alley. Tropical cyclone risk. Hey, you guys are safe in Harlan County. Wildfire risk, winter storm risk, and all those other things. Now, and then they also have that social vulnerability score. Again, I'm not going to get into that. I don't have time. Plus, I didn't really invent it. Other people did. But that gives you an idea of how vulnerable the population is. Sorry. And then other things like agricultural damage, mortality, and other things that I don't deal with on a daily basis, but you may. And you may need to know some of these values, or at least be able to compare them. Here's some more information. I'm just going to pop that up there on top. This all comes out of that one click on that census tract, all these different variables, if you will. Okay. It's a lot, people. So I don't blame you for saying, you're going over my head, Doug, or you're showing us too fast, but I don't have a lot of time. So whoop, I'm going to keep going. So there's that tool. And you can see, you can go, anybody can access this at any time. It's on our website. It's very popular, by the way. Whoop, we're going too fast. All right, more disaster pictures. That's by Elkhorn. The one on the left is Elkhorn after 2019. There's the Missouri Valley after 2019. That's a fire anytime in Nebraska with I guess a pumper truck out there trying to put it out. Okay, so instead of, I can't, again, don't have time to go into all, and this isn't all, but a lot of the issues that will be enhanced, you could say, by climate changing over time. Some of these we've already begun to realize. Some of these maybe not so obvious in Nebraska. Health for sure. Smoke, my goodness. Not last year, but the years before that, I don't know how many years in a row we had smoke, not necessarily from Nebraska or even a state next to Nebraska, but it got to us, right? Heat, definitely. There's a heat.gov website. I'll talk about that slightly a little later. Allergies. What's going on with the allergies? Why are more people having allergies? Why is the season so long where it didn't used to be so long? Of course, invasive diseases for everything, not just humans, animals, plants, crops, whatever. Water quantity and quality goes without saying. Too much, too little. And then the quality issue too comes into effect. Drought and flood, of course, go hand in hand. Flash drought as well as flash floods. And rural and urban have different issues in terms of what that means to both of them. And then, of course, it also has impact on energy production, or if you don't have enough water in the stream to cool off the energy production, there are some issues. That happens. And then we talked already about cascading issues from one severe or one extreme can cause another extreme to happen. Also, things like migration, people moving, can also affect supply chains. My goodness, we've seen supply chain issues over the last few years. Not all climate change related. Many of them were COVID related, but it does give you a taste of what it's like if a particular factory or something on the coast gets wiped out by a hurricane. How are we affected by that? These are all things to think about. Infrastructure, of course. Transportation, we already talked about I-29 being shut down in 2019, and as well as lots of other transportation, right? Utilities affected, et cetera. In 2021, the cold snap, kind of an anti-climate change thing, right? Rural implications, people don't think, when I say people, what am I saying? The masses don't really understand that outside urban core, where it's really bad, it can be really hot inside the city, urban issues or rural issues can also have heat health issues as well. Just ask rural health if that's an issue in the middle of the summer with people coming in being too hot. And increased heat is not going to help that. Ecosystems, of course. Can ecosystems change as fast as they need to keep up with this climate change? In some cases, yes. In some cases, no. And then equity. Gosh, we're all getting, and rightfully so, better understanding how vulnerable populations are being impacted by small and large disasters and such. Okay, I threw this in here. I know this is not Nebraska, but for the most part, just a little bit. But U.S. wildland fire acres consumed from a smoke point of view and from a fire point of view. And I tried to find it, and I wasn't able to. If there was a record of this in Nebraska, like acres burned by state, I would love to see this kind of thing. Just say how many acres were burned over the last 30, 40, 50 years. Is it going up in Nebraska or not? This is the U.S. for the most part, and a picture of a fire. I think it was last year in western Nebraska. Although you had one in northeast Nebraska too, I believe it was last year too. Yeah, there's some fires in northeast Nebraska, which is a little unusual for a big fire anyway. Extreme events tend to cause multi-stressor situations. We've sort of talked about this already, and I'm not sure, Adele, if this is where you wanted to stop or not. Because I can talk about, this says it all here, various sectors interacting and interdependent in all these different ways, and how wildfire chars on a California hillside, and then a river dumps a lot of rain, then an atmospheric, well, we call them atmospheric rivers, but they're just big storms, dump a lot of rain on that hillside, and it causes landslides and all these other things. So do we have examples like that in Nebraska? And I think you wanted to say something.
I think one thing that I wanted to say, because I'm a mitigation planner here with the department, and I review a lot of mitigation plans. Hazards that are of greatest concern for our communities are flooding and drought, and the mitigation for these really goes hand in hand, and they are, these are two hazards that solutions for one can be solutions for the other in a way, or like mitigations for one can be mitigations for the other. But I think it's really important that we remember that drought conditions, they can, we don't have the extreme slopes that you might find in California or Colorado, but here where it's quote unquote flat, you'll still lose the absorbency of the soil. You'll still lose the capacity of our ground to be recharged, to hold water, to slow runoff. So it's true in our setting as well that drought is going to exacerbate in our flood scenarios. So it's just good situational awareness.
Yeah, and if you ever pour water on really dry soil, it runs off, which is interesting, unless it's sand, of course. And Nebraska is blessed by sand hills, right? Of course. Sand hills, I'll tell you, they're the best thing. Moving on. Let's see, are we moving on? Yes. Okay, so we're talking here sort of specifically about heat health deaths are projected to outweigh reductions in cold-related deaths. So more people are going to continue to die from heat issues than they are from cold-related issues. There's a great site out there called heat.gov in this National Integrated Heat Health Information System. It's worth a glance at. They call it NIHIS. If you've never heard of it, it might be worth going to and looking at it a little bit. These two maps basically show, based on a lower emissions scenario, lower CO2 emissions scenario. That means less greenhouse gases. Wait a minute. It means not as much greenhouse gas, and then the high scenario, which is sort of not changing the amount of fossil fuels we burn. The red dots on the right side, and talking about mortality rate of deaths per 100,000 people rising quite a bit based on those two scenarios. I think that's probably by 2100. So here are the temperature projections. I'm going to make sure I say this right. These are the lower emissions. It means CO2 levels and greenhouse gases are still going up, okay, but not at the current or even exacerbated rates. Okay, this is what would happen even if we continue to increase, it's called a medium emission scenario. What would temperatures look like over the northern plains? All right. And annual temperatures are expected to increase 5 to 6 degrees. You know, it's hard to know what that means until we're going to get to what that means in just a minute, a little bit. And then winter and spring experience the largest increase. Frequency, intensity of heat spells projected to increase, and risk of frost damage to vegetation may not substantially change. We saw in 2012 a very warm year, right? We started off very warm. We were in the 80s for like 3 weeks in March. It was crazy. What happened was we had basically dormancy break. Plants started growing, buds came out, flowering, everything. And then we went back to normal to slightly below normal in terms of temperature in early April, killed a whole bunch of stuff. It was not good. So that's the risk of frost damage. We may see these periods in January or February or even March and get warm, right? We may get warm for a couple of weeks. Everything goes crazy. All the plants and animals go crazy, and then we go back to normal or even slightly below normal, and it's not good, right? So that's why that risk of frost damage to vegetation may not substantially change much is in there. That sort of warning sign. You can see the greatest warming there is in winter. Summer not so much, and fall not so much, and summer a little bit more than that in terms of temperature. Here's precipitation. Precipitation is a lot harder to guesstimate than temperature, though. Not to say it's wrong, but just to say it's the probability is, of being right is less. Annual precipitation expected to increase, the largest increases in spring and winter. Okay, that's not all bad. Plausible decreases in summer, that's bad, if that's the case. So that's when we need the water, that's when things are growing. You can figure that one out. High confidence that future storms and precipitation events will be more extreme. In other words, if you get your rain, you're going to get it all at once, which is not something we like either. Heavy rain, less heavy rain, more heavy rainfall events is not good. And this whole idea of aridification, especially in the Southwest, but you can see it kind of creeps up from the Southwest into the high plains of at least Kansas and maybe portions of Nebraska. But what this is really saying is, gosh, has the atmosphere, the Earth system, if you will, changed enough to just say, okay, we're just sort of in this eternal drought? Well, is eternal drought a thing, or is it just the way things are? In other words, is that the new normal? We talked about that a little bit earlier when we talked about the Southwest having a 20-year drought. Well, is that normal? Apparently it is. Even looking back at without climate change, there are long periods of drought in the Southwest and other parts of the country. And we've had the 1930s in the plains. If we had 10 years of drought like they did then, now we'd be hurting. That's without climate change, by the way, or not much. So we also know that there would be more water taken off the land through evapotranspiration. So that's evaporation, just straight up evaporation, heating up water and having it evaporate, as well as plants, crops, whatever, evapotranspirating a lot more water into the air. So both those things are going to happen on a greater scale with warmer temperatures. Increased risk of flash flooding or flash droughts and flooding, for that matter, is something I just talked about in terms of increased evapotranspiration. Thirst, we call it a thirstier atmosphere. The atmosphere becomes thirstier because it can hold more water. It's hotter. It's going to suck, if you will, more water off the landscape, and thus lead to things like what we saw in 2017 and it happened really fast up there in Montana, and the Dakotas got very dry very quickly. So, and then of course, goes without saying, cascading consequences of heavy rainfall in urban systems that aren't used to or made or they're old, then maybe they're not ready to handle the, if you will, new heavy rainfall events like we had originally planned for. So there's going to be a lot of cost, more pollution, potentially more waterborne diseases and those kinds of things. And of course, transportation and lots of other effects as well. And also vulnerable populations such as urban centers, older adults for sure, disabled, low-income communities, and children. There's lots of information out there to stay sort of attuned to what's going on in the climate world in real time. We'll call it real time. One thing we do is a webinar every single third Thursday of every month. You're welcome to join that. It's public. State climatologists, even Martha Scholsky, you're a state climatologist in Nebraska, volunteers to do it every once a year or so. I get them from all over the Midwest. So you're welcome to join those. You can email me if you want to be asked on that list or any other kind of information you want. I have a list. We also put out quarterly summaries for outlooks from the Midwest Great Lakes and Missouri Basin states. Moving on. I wanted to introduce you all to the Climate Mapping for Resilience and Adaptation website. I think you'll be very interested in this if you need answers in terms of what climate change means for a particular area. This is the front page, if you will, current hazards for wildfire, drought, inland flooding, coastal flooding, and extreme heat. This is more active in the summertime than the winter. I'm focusing here, I'm zooming down, if you will, to Lancaster County. I'm sure I'm on a particular track, but I don't know which one. And it allows you, basically this tool allows you to go in it and you can see, well, I think I have things to click on here. You can pick your category of disaster, and this is really for climate change issues and what's going to be happening with wildfire, drought, extreme heat. What's it mean when we say lower emissions, higher emissions? What's it mean in terms of number of days above a particular, in this case, threshold of temperature? How many days are going to be over 105 with a higher emission scenario? And I can't remember if this is the early century. Okay, by 2044, for example. Okay, you can also pick different. Okay, we talked about that already. You can pick your own tract or county, whatever you want, or tribal land. And then you, like I said earlier, you can sort of play around with the different variables in this case. And there's early century, and I think there's late century. So you can look at 50 to 100 years from now as well. And then finally, these bar graphs the bar graphs right there kind of show you the annual days of maximum temperature over, in this case, over 90 degrees. What is that number? Yeah, number of days you're going to see increase over that period of time. Okay. Also looking, this is a way of looking at, okay, back up. This is a way of looking at Lincoln. This is, I selected annual days with the maximum temperature over 95 degrees at the late century time frame with the higher emissions. So that means a lot of CO2, a lot of greenhouse gases over a long period of time. At 2100, how many days a year? So we say it's going to increase 5 degrees a year. What's that mean on an annual basis? What's that mean for a temperature like 95? Well, in this case, in this scenario, it means that we're going to have 76.7 days of 95 plus by the end of the century in Lincoln. Okay, that's a lot of days over 95. I cannot remember what normal is for Lincoln. But it's not that many. It might be 10 or 20. I don't know. You also can get a complete report, which I'm going to show. Oh, okay. I'm going to move on from this to there. You can get a complete report for whatever tract of area you want from that little arrow I showed you up in the right-hand corner. You don't have to go through all that stuff. You can get it's I don't know how many pages, a 5-page report, HTML file. You can bookmark, whatever. You can print them. And it gives you lots of great information on a spreadsheet, or kind of a spreadsheet type thing. Okay, there's climate.gov, drought.gov, weather.gov, and heat.gov. Just wanted to point out that those do exist, and they all have useful weather. I know most of you know about weather.gov, I'm guessing. And there is also this thing called the Climate Resilience Toolkit, which shows you examples of what people in your area have already done. There's regional aspects to that in terms of climate adaptation and mitigation, as well as some of these tools mixed in with that. Back in a previous administration, a couple of administrations ago, We were told, we being the feds, were told, hey, there's too much stuff out there from everybody. Put it in one place so people can find one place to find it. These are, if you will, scientific, but supposed to be easy enough to understand for the layperson reports. We're going to put a new one out at the end of 2023 that details the science of climate change, as well as different aspects like sectors and geography. So there's a Northern Plains chapter, for example. There's a tribal chapter, there's an agricultural chapter, there's a water chapter. So I just want to point that out. I was just out at Hoover Dam. That's what it looks like on both sides. Had a great tour. It's low. It's 170 feet below normal, and it's going to be a problem if more rain or more snowfall and rainfall don't happen in the Southwest. On we go. It's not worried about that today. Looking back at January, this is one thing we do in terms of monitoring the climate. We look at where we rank as a state, in this case, in terms of temperature on the left and precipitation on the right. There's 129 years to play with here, and Nebraska was 127th wettest out of 129 in January, which is good, really good. The only problem with it is the average precipitation in places like Valentine, Nebraska, are 30/100ths of an inch. So it's a dry month. We would like to see 127% maybe in, let's say, April or May. Maybe that would be better. So in other words, more water, maybe you won't get your crops in, but we'd like to see higher numbers later in the year. Here's last year as a whole. The ranking of Nebraska was 4th driest of all time. January, okay, yeah, last year, 2020. And then if we even have this down at the county scale, those dark counties were never drier, okay? And you can see the really dark counties, record driest, and some of the other counties around them. All this, again, is online. One can find this information if you'd like, or I can help you find it if you can't. Nebraska temperature trends over the last 130 years. The trend is increase 1.5 degrees per century. In the Panhandle, it's a little greater. And in the southeast part of Nebraska, I picked both ends of Nebraska, 1.3 degrees. So a little slower warming, if you will, in the southeast than in the Panhandle. Precipitation doesn't look like much, but 1.23 inches per century. I should have looked at the last 30 years or something like that, but I kind of showed that earlier. But anyway, this is Nebraska. Southeast Nebraska is getting wetter faster than the Panhandle. That makes some sense. It makes sense anyway, because the southeast part of Nebraska is a lot wetter than the Panhandle. But the eternal question, have precipitation increases been able to keep up with rising temperatures? That's something to always consider. And the fact is that we don't think they are in some arid areas like the Panhandle. So precipitation percent of normal and deficit over the last 3, 2, and 1 years. You can see 1 on the left, 2 in the middle, and 3 years on the right. This is basically looking at what the percent of normal was. This is maybe not as important. It's been a 3-year drought, right? This is maybe not as important as looking at the actual departure from normal in terms of inches. So the last 12 months, this dark area here north of Lincoln is something like 12 to 15 inches below normal. Over 24 months, and by the way, all the yellow, anything yellow or to red is below normal. You see up in 24 months that really dry up there, over 20 inches below normal around Sioux City. And then 36 months, if you take 3 years in a row, you see a lot of area around Nebraska, especially in the east and on the southwest, being extremely dry. So I believe it hasn't been a 3-year stretch like this, has never been this dry since the 50s and the 30s. We've never had, but it hasn't been that dry since then for a 3-year stretch. And this is only looking back to 2000, but this is a way of, again, looking at Nebraska as a whole. You can break this down to smaller units if you want. Looking at Nebraska as a whole in terms of the drought monitor categories. So D4 being the worst, that dark red, and the light yellow being abnormal drought. Sorry, I'm going fast. Here's the temperature and precipitation since October 1st of this year. It's been cooled. The green colors on the left indicate cooler than normal. Yellow indicates warmer. Not really a big spread there. Here's normal percent of normal precipitation on the right. You can see that track from Colorado, sort of north and east through western Nebraska, northern Nebraska, and into South Dakota being where all the snow fell over the last few months, and in Montana. But there's this continuing dry sort of trend across western Kansas into eastern Nebraska. Here's looking at the last 30 days. Same idea. Cool in the west, sort of warmish to the east. But not super warm, a little warmer to the north. And then on the right, normal percent of precipitation, but don't be depressed because this time of year, again, is not the wettest time of year. So even though we're at 50 or 25% of normal, it doesn't matter as much this time of year as it does later in the year when we are supposed to get heavier rainfall. This is just looking at snowfall, or snow water equivalents in the Rockies this year. By the way, I've shifted sort of into modern day real-time climate information. All this, again, is online. You can find us in lots of places. Looking at that sort of oval area, that's where our water comes from. Probably for Nebraska, you want to know that the North Platte is well above normal and the South Platte is kind of normal. But anyway, North Platte has a lot of water coming down this year, which is a good thing. So far, we're about 75% through our accumulation season. There's this is as of yesterday. Yeah, yesterday around noon. So the snow hadn't all fallen by then. But anyway, showing that there was a lot of snow across the northern part of the U.S., north central part of the U.S. And this is snow water equivalent, by the way, as opposed to just snowfall. Soil moisture, one thing we have to deal with in Nebraska and everywhere else is the lack, since we've had 3 years of really dry conditions, our deep soil moisture is hurting. And we're going to get rains and we're going to get snow melt and we're not going to see a lot of rise on our streams, probably, because for a number of reasons. But the main reason is a lot of that's going to be going infiltrating into the soil column. So we're not going to see the runoff that we normally do. Unless it gets a lot wetter, a lot sooner. This is looking forward. This could be updated. But anyway, this is looking forward to the next 7 days, accumulating all the precipitation that could happen over the next 7 days, according to the models, showing eastern Nebraska getting a little wetter and most of Nebraska not getting a lot of wet, but some. But it's a stormy pattern that we're in. So if we look at the week 2, March, next week beyond next, is we see this cold, the probability of cold temperatures in California and the West, extending into Nebraska, by the way, is going to continue. That's a good sign. That's a good thing. And you also see that above normal category on lower right showing us above normal chances for precipitation. That means the storm track is going to continue coming through California, which is a great thing for them, of course, but also for us. So that's good. That's all good news. And then the March overall outlook for March is this continuation of below normal temperatures to our north and really equal chances for above, below, or near normal for Nebraska. I would probably update this today and say more. We'll see. This gets updated in about a week. Nebraska may be in the above category by then. These are leanings, by the way. These are not absolute predictions. We're leaning towards being a little bit wetter. And then looking at a little bit further March into May, below normal temperatures, more likely in the north, and really Nebraska stays in this equal chances. I'm sorry, but that's the way it is in Nebraska. We're caught between north, south, east, west. We're right in the middle. Same thing when we're looking at the summer, and I don't put a lot of emphasis on the summer outlooks because we're at this time of year, it's very hard to predict what's going to be happening in the summer in terms of temperature and precipitation, especially precipitation. But definitely in temperature, we just don't have a good feel for it in Nebraska. There's your current drought. Well, it's not the current one. The current one just came out this morning, and I didn't update this, but basically it didn't change that much. Still extremely dry in the Northeast. A lot of soil, dry soils up there, especially in the West, and in the West too, and in the Panhandle. Over the last 8 weeks, things have improved a little bit over parts of Nebraska. That's the upper right. But 52 weeks ago, we were in a lot better shape. And that's that map in the lower right shows you how much we've worsened over that time. So we've gotten, I think it's three categories of drought worse in Northeast Nebraska, for example. There's the drought outlook. It's good news. Basically, where it's brown, that's bad news. Bad news where it's brown, because that's the prediction is by May 31st that there's no improvement predicted. On the other hand, where it's gray, there is improvement predicted, and where it's green, the prediction is for the drought to go away by the end of May. Yeah. I don't know if I have time for this, but we're transitioning out of La Nina into neutral this year. What does that mean? May not mean a lot, but El Nino may be coming in the fall. There are some models kind of pointing to El Nino. El Ninos tend to be a little bit warmer and sometimes wetter across Nebraska, to be honest, especially to our south. We have a good snowpack in the mountains this year. We have good snowpack in the plains so far this year. That's good. It's not worrisome. It's not worrisome like we were in 2019. It's not that bad. We have a lot of ground to make up. The soils are not that frozen, hard, packed, and all that stuff. And then the outlook is right there. And then I'm advertising our webinar there at the bottom, but we can share this later. This is what I do every day. I have this discussion with myself. And I don't know, Adele, if you want me to go to these extra slides or not, but
we better save that for another time.
All right. Thank you.
Yeah, I get a key takeaway here with adaptation is, we aren't going to engineer ourselves like solutions that protect us from these extreme weather events and associated consequences. So adaptation is really, we need behavioral changes to go with our mitigation actions. So I guess those of us who are floodplain administrators and we're protecting floodplains from development, or we're reducing the encroachment of impervious surfaces in our waterways. These are steps that are very important towards mitigating the effects of climate change on our communities, and whatever we can do for adaptation to shift our behaviors within our communities is beneficial. Thank you, Doug, for this thorough presentation. It was a huge topic that we tasked you with. Obviously, there's plenty of ground to cover.